Good morning everyone. Welcome again in physics class of measurements and experimentation. Firstly, I will introduce about the syllabus. That is number 1 point, International System of Units. The required SI units with correct symbols are given at the end of the syllabus. Other commonly used the system of units, MKS system, CGS system and FPPS system. Second point, measurement of using common instruments, vernier calipers, micrometer and screw gauge for the length and simple pendulum for time. Understand? A point, system and unit of SI system. Need for the measurements. Physics, like other branch of science, require experimental studies which involves measurements. What is the meaning of measurements? Measurement is the assignment of a number to a characteristic of an object or event which can be compared with other objects or events. Right? Measurement is the process of comparison of the given physical quantity with the known standard quantity of the same nature. Very important point, children. Important point. Measurement is the process of comparison of the given physical quantity with the known as standard quantity on the same nature. Right? The standard quantity used to measure and express the given physical quantity is called the unit. Right? If we say that is 1 Newton. 1 is the magnitude and Newton is the unit. Right? 1 is the magnitude and N is the unit. The unit is the quantity of a constant magnitude which is used to measure the magnitude of other quantities of the same nature. What is the meaning of experiment? Experimental studies are ones which research introduce an intervention and study the effect. It is usually randomized, meaning the subject are grouped by chance. Right? Important point, the unit in which the quantity being measured. The second point, the numerical value which express how many times the above selected unit is contained in the given quantity. Thus the magnitude of physical quantity is expressed by physical quantity is equal to numerical value into unit. It is very important point, that is physical quantity is equal to numerical value and unit. Just for example, 5 Newton. 5 is the numerical value and N is the unit. Now consider 6 ampere. That is 6 is the numerical value or A is the unit. Right? Choice of unit. Since a unit is to be used universally, so it should have validity everywhere at all times. Hence, to measure the physical quantity, the unit chosen should have the following properties. The unit should be of convenient size. Second point, it should be possible to define the unit without ambiguity. The unit should be reproducible. The value of unit should not change with the space and time. Very important point. The value of unit should not be changed space and time. For example, small g equal to 9.8 meter per second square. It is constant. 9.8 is constant everywhere and meter per second square is the unit. 9.8 is the numerical value and meter per second square is the unit. What is the g? G is the experimental value. That is small g is the acceleration due to gravity. It is universal constant. It is the universal constant. Okay, now I will explain kinds of unit. Units are of two kinds. Number one point, fundamental or basic units and derived units. Fundamental or basic units. A fundamental or basic units is that which is independent of any other unit or which can be neither be changed nor can be related to any other fundamental unit. Just as listen, please remember it. Example, the unit of mass, length, time, temperature, current and the amount of substance are independent of each other as they are different nature. They cannot be obtained from the unit any other quantities. These are fundamental units. In other meaning of fundamental units, each of a set of unrelated units of measurement which are arbitrary, defined and from which other unit are derived. For example, in the SI system, the fundamental units are in meter, kilogram and second. Right? What is the unit of length? That is meter. What is the unit of length? Is the meter. Length is unit meter. Mass unit is kilogram. Time unit is second. Right? It is the fundamental unit. L, length, breadth, height, mass and time. Right? Next, second, derived units. What is the derived units? Derived units are those which depend on the fundamental units or which can be expressed in terms of fundamental units. Understand? For example, we know that area of rectangle is length into breadth. That is, length, unit of length is meter and unit of breadth is meter. That is, unit of area is meter square. Right? Next, well, volume of cuboid. Volume of cuboid, that is length into breadth into height. That is meter into meter into meter. That is meter cube. Understand? It is the derived unit. Length, breadth and height is the fundamental unit and volume is the derived unit of the fundamental parts. Right? Next, if we consider speed equal to distance upon time, that is meter per second. Meter and second is the fundamental unit and meter per second is the derived unit. Understand, children? Speed equal to, it is the formula of speed, that is distance upon time. Unit of distance is the meter and unit of time is the second. Therefore, meter per second is the derived unit and meter and second is the fundamental units. Understand, children? Okay.